Saturn's moon Mimas looks like a skull. That crater shouldn't exist, and what lies beneath it might rewrite planetary science. In 1789, William Herschel pointed his telescope toward Saturn and discovered something small and distant. He called it Mimas. For the next 2 centuries it remained just a name in an astronomy textbook, a moon too faint, too far away to tell us anything. Then in July 1980, Voyager 1 flew past Saturn. The images it sent back stopped planetary scientists cold. One of those images showed a world that looked nothing like what anyone expected. Mimas is small, only about 396 kilometers across. For scale, you could drive across it in a day if gravity let you. But what made Voyager 1 cameras go silent for a moment was this: covering nearly a third of its surface is a single crater. A crater so massive, so perfectly formed that it dominates the entire moon's face. Astronomers immediately gave it a name, Herschel. And when the first high-resolution images loaded into NASA databases, one joke spread through every planetary science lab on Earth. It looks like the Death Star, not metaphorically, literally. The resemblance is so striking that when George Lucas saw the Voyager images years later, he claimed the designers of the Death Star for the original Star Wars trilogy had never seen them. Whether that's true or not, the nickname stuck. Herschel crater is 139 kilometers wide. Its walls rise 5-6 kilometers high. At its center sits a central peak that juts up another 9 kilometers. It is, without question, one of the most violent features in our solar system. But here's what planetary scientists didn't know in 1980. That crater should have destroyed Mimas entirely. That's the question that haunted impact researchers for decades. When an object the size of a small mountain hits a moon made of ice and rock at speeds exceeding 20 kilometers per second, the energy released is incomprehensible. We're talking about an explosion millions of times more powerful than a nuclear weapon. Most moons wouldn't survive that. Mimas should have shattered into fragments. The impactor itself was enormous. Calculations suggested it was somewhere between 10 and 20 kilometers across. It struck Mimas roughly 4 billion years ago in the early chaos of our solar system, when collisions like this were far more common. The impact released energy equivalent to a 10 billion megaton explosion, and yet Mimas held. The moon didn't break apart. Why? The answer lies beneath the surface. Mimas is mostly ice, but not the brittle frozen water you'd find on Earth's glaciers. This is ancient compressed crystalline ice, the kind that exists in the deep cold of space. When the impactor struck, the heat from that collision did something unexpected. It liquefied the ice around the impact site, turning it briefly into slush. That slush flowed like water. It absorbed the shock waves. It redistributed the impact's energy across the entire moon. In essence, Mimas survived because it's made of the right material in the right amount. A moon made of solid rock would have shattered. A moon made of softer ice might have deformed beyond recognition. Mimas, with its particular density, its particular composition, its particular internal structure, was strong enough to flex. It bent under the blow without breaking. The crater we see today is a scar from an impact that should have been fatal. But what scientists didn't know in 1980 was this: there's something hidden inside Mimas, something that wouldn't be suspected until decades later. In 2023, a team of researchers analyzing Cassini spacecraft data made a startling discovery. Mimas shows signs of harboring a liquid water ocean beneath its icy crust, not a frozen shell. Liquid water, moving, churning, potentially, just potentially, alive. The evidence is subtle. It comes from precise measurements of Mimas's orbit, the way it wobbles slightly as it moves around Saturn. That wobble suggests an internal structure that shouldn't exist if Mimas were simply a frozen ball of ice. The measurements indicate the moon's core might be shifting, moving in ways that only make sense if there's liquid water trapped inside. If that's true, the Herschel impact didn't just scar Mimas. It may have fractured the crust enough to allow liquid water to persist beneath the surface. Think about what that means. A tiny moon, smaller than our own moon, orbiting Saturn at the edge of the solar system. A moon that survived an extinction-level impact. A moon that's been silent, seemingly dead, for 4 billion years. And now we're discovering it might harbor an ocean, might harbor the conditions necessary for life. The very impact that should have killed it may have been the event that made it habitable. This is still speculative. The data is preliminary, but it represents a fundamental shift in how we think about small moons. For decades, we assumed that only large bodies, Jupiter's Europa, Saturn's Enceladus, could harbor subsurface oceans. Mimas was just a curiosity, a Death Star, a reminder of cosmic violence. We didn't look deeper. We didn't ask what lay beneath that famous scar. The next chapter of this story will be written by future missions. NASA and the European Space Agency are both considering dedicated probes to Saturn's moons. If Mimas is selected, if we send an orbiter or a lander to that distant world, we might finally answer the question that's haunted us since Voyager 1 sent back those first images. Is there really an ocean beneath that crater? And if there is, what does it contain? Mimas teaches us something essential about our solar system. Impact scars are not just records of violence. They're fingerprints of survival. They're maps of possibility. The crater that looks like a Death Star may actually be the signature of an impact that preserved conditions for life itself. In space exploration, the most profound discoveries often hide in plain sight. waiting for someone to ask the right question. Subscribe to this channel. We cover the untold stories of space exploration, the moments when what we thought we knew gets overturned by a single image, a single measurement, a single question asked by someone brave enough to look closer. Subscribe to uncover the next discovery that rewrites what we thought we knew about space.